Okay, so let's illustrate how we can explore parameter sensitivity analysis within the program. And this provides insight as to what may be limiting fraction absorbed for a particular compound. So as we've seen before in this graph, we suspect that these compounds in this particular area of the graph are most likely permeability limited compounds. So we can investigate that at a higher level of depth using our parameter sensitivity analysis tool. And the way we would do this is, for example, select this compound, and then using this button over here to update the spreadsheet, we can see which compound that is. So here we go. And now going to our parameter sensitivity analysis icon here, open the corresponding setup dialog. So we don't necessarily need to do this for 2 doses. We can just take, say, a 10 milligram dose to look at this. Of course, we want to select the same physiology, human, that we had before, and also the same dosage form, being an immediate release tablet. And now what the program is going to do is vary both solubility and permeability and see how the fraction absorbed is projected to change as a function of that. So what you see here is that the scale for changing solubility is pretty different from the scale for changing permeability, and that's because these two models have very different ranges. There's a much larger range of solubility within our solubility model and solubility in general. Of course, it's based on experimental data, whereas that range is much smaller for permeability. So what we're going to do here is, again, select this compound and run a parameter sensitivity analysis. And what the software does is it returns a curve which shows us that if we fix solubility, so this is the simulated calculated solubility and permeability for the compound, and then on each side we have runs with simulated values, different values of permeability in this case, and solubility here. So the program does 8 runs with different values for solubility and 8 runs with different values, 4 on each side, okay, for both solubility and permeability. So in total, 16 simulations changing one variable at a time. So what we see here is if we fix, say, permeability and change solubility, there's literally no effect on the projected percent FA, and that is because the compound, as we intuited over here, is a permeability limited compound. Okay. On the other hand, if we fix solubility and vary permeability, then we see that we can potentially affect fraction absorbed, the predicted fraction absorbed, to a considerable effect. Okay, so that is one observation that we can make. Now, we can close this one and we can actually go back to the graph that we had previously. Remember that we had the inverse graph before, where we had graphed percent FA as a function of the jejunal permeability, and then we had colored our points with solubility using a log scale. Okay, so that's the graph we have before. And what we see is that in this case, we have compounds which we project. These are projected to be solubility limited compounds. And how would we investigate that at a higher level of detail? Well, in the same way. So we can select this compound, see which one it is, and then go back to our parameter sensitivity analysis tool and do the similar calculation. Okay, so we're going to take same physiology, dose, etc., and perform the run. And now we see the inverse situation where if we fix solubility, again, this is the model value for both solubility and permeability, and we investigate with the same way, 4 runs on each side, high and low, varying solubility by 250-fold on each side, and permeability 2.5-fold on each side. So again, we're doing a total of 16 runs. If we fix solubility to this point and modify permeability where there is no projected change in the fraction absorbed, because we have a solubility limited compound. Okay. On the other hand, if we fix permeability and we vary solubility, then we can potentially get a pretty dramatic effect on the projected fraction absorbed of that compound. So in this case, it would be very useful to seek enhanced solubility for this particular compound and rescue it, since it is the solubility parameter that is gating the fraction absorbed. So anyway, I hope that was a useful analysis, and you can see how we can infer even from this graph what the projected behavior of the compound is likely to be. And again, with the parameter sensitivity analysis tool, we have the ability to investigate this at a much higher level of detail. Okay, so let's shift gears and see how we can use experimental data as part of an HTPK simulation. What's important to understand is that HTPK is not an all or nothing situation. You can calculate PK parameters at a high throughput, all in silico, so that is entirely from structure if you so desire, but you can also use and should use experimental data in order to bring more accuracy to the simulation if this data is available to you. So let's go back to this data set that we used previously, which is this subset of this enamine diversity set. So we're going to load these 2,000 compounds as we've done before. And now we're going to hypothesize that we have experimental solubility data for these compounds, and that we want to rerun our previous %FA and %FB calculations, taking this new data into account. So let me first show you what this data looks like, and just open it in Notepad. And this is data that I have generated for the purpose of the exercise to show you how you can do these sorts of things. And that's, again, simulates the case where we would have experimental solubility values for these compounds. So the file assembles the identifier, which is actually essential for making the correspondence with the spreadsheet, and this experimental solubility value that we wish to import. And you notice here that I have actually removed the data for a couple of the compounds just to show you how the software behaves when data is missing. Okay, so let's go now and import these values into our spreadsheet. So we've seen in a previous tutorial how to do this. We go to File, Import, Compound Attributes, browse to find our file with the missing data, and the first line contains the column label, so we don't want to import that. and we'll make the correspondence based on the identifier field of these compounds and import the experimental solubility values. Here we are. So we've imported the values, and we see that we have missing data for compounds 2 and 4. And so what we want to do now is go back to this %FA and %FB panel that we've used before. We're going to use the same human physiology that we used previously, the same dosage form as immediate release tablet. Now, we don't really need to simulate multiple doses for the purpose of this exercise. We can just use the default 10 milligram value that has been entered, and we'll calculate both %FA and %FB. But now, instead of using our native water solubility model, S plus SW, we're going to use our experimental values. And the way you do this is by going into the advanced settings. So again, by default, the software is using our native pure water thermodynamic solubility model. Now what we can do instead of doing this is point the software to this column. So that's what those little 3 dots here are for, this little side box. You can click on this and then now select this column as the attribute selection, this experimental solubility column, and just say OK. And now you could do this for any other property that is involved in the HTPK simulation. So if you had experimental values for permeability or for the blood to plasma ratio or really any other parameter that is involved in the simulation, then you could substitute it. So again, instead of using the model, it could use your experimental values. So you click OK, and now we're going to run using these experimental values. So it's proceeding at about the same speed that we've had before. Again, the software is multi-threaded, so it goes rather quickly. And one of the things we notice is that the software did not complain that we had missing values for the experimental solubility. And well, you're going to ask me, well, how did it accommodate this situation? How was it able to provide the simulated values if it doesn't have the experimental solubility or any solubility value to use? And that's a very valid question. And actually what it did is that it used the experimental solubility values for all of the molecules. However, for those 2 that had missing values, it reverted back to the S plus SW, so the pure water thermodynamic solubility model that we have in ADMET Predictor. And you may also ask me how would I know that it did that? Well, it's because I did rerun the calculations specifically with the model, and the output values for all the parameters came to be the same. So I'm pretty confident that that's what it did. So anyway, again, I wanted to get you familiar with using experimental data as part of simulations. And again, that is something that you can push pretty far, because we provide the ability to revert to experimental data for a lot of the parameters, or at least the most important ones that are involved as part of the HTPK simulation.